I've uploaded this periodic table, so what you'll probably find is you'll never really get a periodic table that gives you everything you want. Usually for our course, we like to find ones that have kind of the charges up on the corners so we know what we're dealing with when we're making compounds and molecules. But for this one to do periods and groups, it'll all be labeled at the very top. So yes, I think these are like the ones you were looking at, right? Like 1, and then it'll go all the way over to 18. But if you look kind of at the third row here, it'll also give sometimes another value. So instead of calling this group 13, we can also call it group 3 technically, group 4, 5, and all the way over to 8. So that will help us with labeling groups and periods the way they have tried to do it in this course. Obviously, you'll also find other times where we'll say like scandium might also be in group 3, period 1, 2, 3, 4. So it's just honestly the method they chose to use. So I can't quite remember what the questions were. I want to say nitrogen was one of the answers, right? So nitrogen would be in group 5 if we're using kind of the format we're using. And the period would be the second period because this would be period 1, period 2, that never changes, period 3, 4, 5, 6, 7. We'll literally never use these ones. It's just when we get into periods 2 and 3, we'll end up skipping from group 1, 2, and pretend there's no gap, 3, 4, 5. Similarly, even though all of these exist, this would be group 1, 2, pretend nothing is here, 3, all the way over to 8. The reason being is that part of our course would be drawing Lewis structures so that anything in this column always has 3 dots for 3 electrons. Anything in this would have 6 dots or 6 electrons. Anything in here except for helium would have 8 dots or 8 electrons.